Hello, my name is Paul Nylander, and I'm with IMC's U.S. partner, IMC DataWorks. In the first part of this tutorial, we already introduced the basic functionality of IMC's FAMOS Reader. In this second video tutorial, I'm going to introduce the data browser. The FAMOS Reader is a free program we offer to people who need a handy way to visualize and document measurement data. Compared to the file browser we introduced before, you can think of the data browser as the alter ego of the FAMOS Reader. It is especially well suited to tackling the problem of analyzing a large, structured mass of data. Because the data browser unifies the three principal parts of the FAMOS Reader, the file browser, the curve window, and the report generator, I tend to use it for almost all of my visualization and reporting chores. So let's start. I'll be analyzing the results from 4 iterations of a measurement where I recorded about 40 channels per measurement. To display, let alone compare, all of these results in most other applications would be entirely too cumbersome. Even with the conventional FAMOS Reader tools, such as the Quick View window demonstrated in the first video, browsing through and comparing different measurements is challenging. Fortunately, the data browser provides the help we need. The first difference to notice is that instead of using free-floating curve windows, the data browser structures the visualization into one or more panel views. The panel can appear as a dialog sized to your screen size, or as a predefined report view corresponding to a page of a printed report. In this way, with the data browser, you're already viewing your data in the final report. So I've created a new panel, or report page if you prefer. Since the data browser is a multi-page tool, it is possible to create and use several reports and user panels all at the same time. Let's start our tour of the data browser over here on the left side. The upper part of the data browser window shows the Windows File Explorer and allows me to easily locate my data. If the directory contains measurement data, it is considered a measurement by the data browser, and a little triangular symbol appears as a button in front of the directory name. Simply clicking on this button will load all measurement data files in the directory into the data browser. As you might have imagined, you now see that once loaded, the measurements window in the middle shows the measurement, and the channel window on the bottom shows the channels which have been loaded from that measurement. Shift or Control clicking allows me to multi-select measurements and load them all simultaneously. Let's take a closer look at the Channels window. Again, this window shows all the channels which have been loaded from the selected measurement in the measurement window. We'll come back to data selection in just a minute. The toolbox on the right side of the data browser window contains my panel design elements, including curve window objects, text elements, pictures, and so on. Common in many drawing programs, I can simply drag and drop elements on the panel area, such as a simple rectangular frame and a standard curve window object. Then I simply drag and drop a channel or channels from the channels window onto the curve window object to include those channels in that window. Just like that, we've created our first simple panel for displaying data in the data browser. Couldn't be easier. I'll go ahead and skip a few drag and drop steps here by loading a more interesting panel which I've previously prepared. This panel, you will notice, has multiple tabs or pages and has been filled with several interesting elements such as curve windows and pictures. A quick refresher. Loading a measurement is easily accomplished by clicking the button next to a measurement folder. You'll see that as soon as I do, the objects in the data browser panel are immediately populated with data from the currently selected measurement. Loading additional measurements can be done just as easily by multi-selecting the measurements and clicking the load button next to any of them. In order to explain how these dynamic updates work, I will start by dragging a single channel from the selected measurement into a curve window. As expected, the measurement channel appears inside the curve window, and selecting a different measurement updates the curve window. Let's have a closer look at what's really happening though. If you watch closely, when I drag a channel into the curve window object, the channel appears along with the measurement index. In this case, the brake pedal X signal from measurement index number 1. The index is shown by the number inside the turquoise field to the left of the selected measurement name. When I select a different measurement, the index number moves to the newly selected measurement, a new number 1. Consequently, the curve window, which references measurement number 1, is automatically updated. You might expect, if I select and drag 3 different curves into the curve window from one measurement, all 3 measurement channels appear with the same measurement index, number 1 again. And as before, selecting a new measurement updates all 3 channels in my curve window. But what happens when I select multiple measurements? You will see that if I select 2 measurements and drag a single channel into my curve window, I get 2 curves, one for measurement index 1 and one for measurement index number 2. It is the same signal, in this case brake pedal X, as seen in 2 different measurements. This can be done for any number of signals. As you'll see, I'll add the brake pedal Y signal into the curve window, again for my 2 selected measurements. Now I have 2 different signals from 2 different measurements, all in one window. With the help of multi-selection, the meaning of measurement index 1 and 2 can be easily adjusted to compare any 2 measurements. Now here is a little trick. You've already seen that by clicking on the measurement name, an index will be created and assigned dynamically. But by clicking on the index field itself, the index can be locked. This makes it easier to compare one or more runs of data against a fixed reference set of data. Clicking the index again releases the lock. By the way, this dynamic index can also be used for channels, as well as measurements if desired, to create a very flexible selection or multi-selection viewing area. For example, you could set up a window to always show the first 10 selected measurement channels, regardless of their names, inside a single curve window. I hope you're starting to get the feeling here that working with indices is both very simple and very powerful, while always maintaining a very clear overview of what's going on. Finally, an additional hint about curve windows. You may have noticed that I frequently drag data channels into a window, but never drag a channel out of a window. So, if you take a look at the contextual menu of a curve window by right-clicking anywhere inside that curve window, you'll find one of my favorite dialogues called More Waveforms. More Waveforms is a structured view of what is displayed in a curve window and how it's displayed. You can easily rearrange, or using the trash can button, you can remove channels, independent y-axes, and coordinate window panes. By the way, as the name of this dialog implies, you can easily add more waveforms or channels to a window by dragging them from the right side of the dialog. You can add independent y-axes and additional coordinate window panes as well by using the buttons at the top of the list. That about covers the basics of the data browser, which is found in the free FAMOS Reader and all other FAMOS editions. I encourage you to check out additional video tutorials as well as download the FAMOS Reader or a demo version of the full FAMOS package at www.imcfamos.com or by visiting your local distributor's website.